In this lesson, we'll be talking about the rename instruction. That is an important instruction in 3D. It is used to change the labels of faces or edges in your geometry. Let's start with this kind of sketch. This is a sketch using a DXF file and then label. Okay? Now we have all our labels in our edges and in our faces. The first method to use, rename, that is here, is the simple method that, for example, rename all faces to west, and then the result is all your faces will be renamed to west. You can rename all the edges, all your faces, to south, for example, and your result will be that the edges in all your faces will be renamed to south. Other method to use it is selecting one label and changing for the other. For example, let's first select the south face, and then in this face I'm going to select the label west and change it for label north. Before we perform this rename, the south have all these labels in the edges, but when I perform this, the west label now is switched to north label. You can change, for example, all the labels in this area. For example, all faces, all edges will change to west, except south, that will be kept as south. The result is this: all edges change its labels to west, but you keep the label south as it is. Another way to use this is randomizing this. For example, in the south area, I will say that west will be east, or west will be north, or west will be south, or west will be west. That randomized in every render of the model, it will select one of these sentences and execute it randomly. As you can see, now I have the west as north, but if I get another model, the west now is west, now the west still west, north again, now is east. As you can see, it randoms the label of the west label of the west edge in the area. Another useful way to use rename is change the labels depending on geometric conditions. Let me remove this, and here you have, for example, edges by condition, and then you can list many conditions that you can use to change your labels. For example, this is about edge by length. Now I have to complete this condition. Let me first, for example, okay, First, for example, the edge will label choose. If I don't choose anything here, it will be anyone. I will rename the edge to whatever edge it have, to north, when its length is minimum 4 units. And it belongs to a fade label, for example, south. The result will be this one. All the labels of the edges of this face match the condition that have more than 4 units. But if I select, for example, the west area, the result will be that only these edges match the condition. This edge was already named as north, but these side edges match the condition, the other doesn't. Other way is using by opposite. I will rename the edge with label whatever to, let me add another label that will be easier. The things will be easier like this. Let's have another label, label 1. Okay? Now I will say with label whatever to 1 when it's opposite to a face label south. The result will be that every edge that opposes to a face south will be labeled as 1. If I filter more here, saying that belongs to a label named east, will only perform in the east face, not in the west face. Sometimes I need more complicated conditions, and for that I have the bindings. Bindings give me the possibility to assign to some variables that only operates inside this node, not in the whole project, only this node, assign to those labels some geometric conditions. When I select bindings, I can make some bindings, for example, to length. I will assign to a binding named L the length of one segment, whatever, and I will assign to the binding W that will be true if for an edge label whatever is opposite an edge label south. Now, using those bindings, I will write my sentence using my expression. I will say rename the edge with label whatever to south when L over 4 units and W is true. Now the result is that the only edge that matches with that condition is this one. Let me name it as 1. Okay? The only edge that matches that condition is this one that have over 4 units at and opposed to another edge labeled south. If I change these to 2 units, for example, the result will be that this one and this one the both match the condition and get the operation of rename. Now let's see one important characteristic. When you make renames depending on opposite edges or opposite faces, all the information of the faces will enter to the rename node. For example, if I only select to operate in the south faces, only the information of that faces will enter the rename, and the result will be that there will not recognize the opposition of this face, which have this edge that was the condition for the opposition. I don't, if important than never, filter the faces before making a rename that have the faces, the opposite faces or opposite edges condition. When you unfilter that, you can now the condition is working again. If you want to filter only in this face and keeping the condition, here you can select and belongs to a face label south, and there will only operate in this face, but will recognize the rest of the faces. As you can see, this one match with condition, but I select only operate in the south face. In the end, I also have condition that operates with faces, rename faces by condition, and now I can rename, for example, by length. I rename all faces with label whatever to 1 when the largest edge with label south are minimum over 4 units, for example, and the result will be this one. This face and this face match the condition because have the south edge over 4 units. I can use opposite conditions, rename all faces with label whatever to 1 when it has any label, let's see, east with opposite to a face label south, and the result will be this. This is the face that matches with the condition, that is the east edge is opposite to a face label south. It's work the same as edges, but in this case referring to faces. And you have also, of course, the bindings to use them and to explore it. With this, we end this lesson and see you in the next lesson. Goodbye.